Welcome back everyone. In today's session we are going to begin the introduction of new chapter. Okay, before we go for that, let's recall what you have learned in your previous classes. Okay, hope you remember the counting numbers. What are counting numbers? 1, 2, 3. Whenever you need to count something, you use these numbers or not? 1, 2, 3, 4, 5 and so on. Okay, so what do we call these numbers? These numbers are called natural numbers, isn't it? Counting numbers are natural numbers. Okay, you have learned about natural numbers. You started your mathematics with natural numbers, okay, when you were in nursery. Then if 0 is added to this, what happens? You know it very well. If 0 is added to these natural numbers, then those numbers are called whole numbers, isn't it? Then whole numbers, in these whole numbers 0, 1, 2, 3 and so on, if I add negative of natural numbers, negative natural numbers, what do we call these numbers? Yes, these numbers are called integers, isn't it? So you have been learning about these things from your previous classes about natural numbers. You learned about whole numbers, you learned about integers, there was a chapter. Okay, then you got a glimpse of rational numbers too. Okay, so there are different types of numbers: even, odd, prime, composite. Okay, and numbers are never ending. Okay, there are never ending numbers. So we are going to see in detail about these types of numbers. So numbers are divided into two families. They are rational and irrational. Okay, basically numbers are divided into two families. One is rational number, another irrational. These both comes in the family of real numbers. So I can say real numbers is the head of the family, and rational and irrational are two kids of real numbers. Okay, so we will classify rational numbers and irrational numbers in detail. I'll explain you what are rational numbers and what are irrational numbers. Okay, so to begin with, let's proceed with the rational numbers. So numbers which can be written in the form of p by q, where p and q are integers and q is not equal to 0. So you might have learned about this definition, about the definition of rational numbers in your previous class. So let's continue with this and see who are the family members of rational numbers and what is the meaning of this p by q. P by q is nothing but any number which can be written in the form of a fraction or p by q. Okay, it is called a rational number and q must not be equal to 0. Okay, if you just perform this calculation on any calculator, you will observe why it should not be 0 because when q becomes 0, then the answer will not be defined. Okay, you will get an error there. You can observe that on calculator. So 5 by 0 is not defined, so that is the reason q should not be equals to 0. Now let's begin. Let's count the family members of rational numbers. Which numbers belongs to rational numbers family? So keep this concept in your mind. Any number which can be written in the form of p and q. P and q are integers. They can be positive, they can be negative, but q should not be equals to 0. This is the rule. Okay, so if I say natural numbers first, are natural numbers rational? Do they belongs to rational numbers family? Yes, all natural numbers are rational numbers. Why natural numbers are rational? Because all natural numbers like 1, 2, 3, 4, so on, they can be written as 1 by 1, 2 by 1, 3 by 1. 3 by 1 is 3, 4 by 1. Okay, so as they can be written in the form of p by q, they all are rational. Then what about whole numbers? Whole numbers, which begins from 0, 0, 1, 2, 3. Even I can write 0 by 1, 1 by 1, 2 by 1, 3 by 1, and so on. So all whole numbers are also rational. Then what about integers? I can write integers also in this manner. If I have -3 or -2 or -1, 0, 1, 2, 3, I can write by 1 for all of them. Does it make any difference? If I write by 1, if I divide -3 by 1, it's -3. There is no change. So all these numbers, natural numbers, whole numbers, integers, they can be written in the form of p by q. So that is the reason they all come under, these all numbers comes under the family of rational numbers. Okay, let's see some more examples of rational numbers. Next, three members we have got. Okay, now all the fractions, okay, all fractions are clearly rational numbers. Like if I write the fraction 3 by 5 minus 1 by 2, negative fraction, okay, or if I write 0 by 1, all these fractions are rational numbers. 1 by 3 is also rational number. Okay, and this is the fourth family. Then all perfect square numbers. Okay, what do you mean by perfect square numbers? Like root 4. What is root of 4? 2. And 2 is a rational number. 2 by 1 is 2. Okay, 2 can be written as 2 by 1 or not. 2 I can write as 2 by 1. So this is p by q form. Root 9 I can write 3 and 3 by 1. Okay, so 3 by 1, 3 is a rational number. So root 9 is also rational number. So all perfect square numbers are also rational numbers. Perfect square number. All the perfect square numbers are rational. Then what about non-perfect square numbers? Like root 2, root 3, root 5. Are they rational? No. These numbers are not the member of rational family. These are irrational numbers. Okay, so I'll explain you what are irrational numbers. So we have got the members of rational number family, all natural numbers, whole numbers, integers, all the fractions, okay, all I can say perfect square numbers are also rational. Let's have a look at another example of rational number. So how many types of decimals do we have? You have learned about decimals. So how many types of decimals do we have? Let's have a look at that. So there are three types of decimals. Okay, one is terminating decimal. Terminating decimal means, like if I write 1 by 2, what is 1 by 2? It's 0.5. Okay, so decimals of this type, 0.5, 1.5, 2.3, which ends, okay, these type of decimals are called terminating decimals. So all terminating decimals are also rational because they can be converted into p by q form. Like 0.5 I can write as p by q form, that is 5 by 10. 5 by 10 is how much? Again, it's 1 by 2. So this decimal, this is terminating because it is ending. Okay, this is ending, that's why it is called terminating. So all terminating decimals belongs to rational numbers family because they can be converted into p by q form again. Then there will be another decimal. Next, if I have a fraction like 1 by 3, divide 1 by 3, let's see what happens here. So 3 and 1 here, so I cannot divide 1 by 3, so I'll take 0 point and 0 here. 3 times is 9, then remains 1. I can take 0 because I have taken the point here. Then again 3 times is 9, then again the remainder is 1. I can take 0. Then 3 times is 9. So till when it will continue? This will never end. Yeah, isn't it? So what is the decimal expansion of 1 by 3? It's 0.3333, goes on, which is never ending, non-terminating. So this type of decimals are called non-terminating decimals. So the answer for 1 by 3 is 0.33333, goes on, which never ends. So we write it as 0.3 bar. So these type of decimals are called non-terminating repeating decimals. What do we call them? Non-terminating repeating. Okay, decimals, non-terminating repeating. Okay, they are not and they are never ending, and this number something repeats there. Okay, so this type of decimals. So let's count now the family members of uh, rational numbers. All the non-terminating repeating decimals are rational. All the terminating decimals, okay, all the terminating decimals are rational too. Then all the perfect square numbers are rational, and non-perfect square numbers are irrational. These numbers are non-perfect, they comes in irrational. So this is the third member. Then the fourth member, all the fractions, then all integers, whole numbers, natural numbers. So these all comes under the family of rational numbers. Okay, very big family, isn't it? Very big family. Now let's have a look at irrational numbers. So just now I said you irrational numbers. Now there is another type of decimal which is non-terminating non-repeating. What? Non-terminating. Just now I gave you an example of decimal, non-terminating decimal. Okay, then again we have non-terminating. Third type of decimal, terminating non-repeating. Non-repeating. Okay, non-terminating non-repeating decimal. So this is the third type of decimal. The first type of decimal is terminating. The second type is which is rational, and the second type is non-terminating repeating. So we can convert even 0.3 bar into p by q form. There is a method for that. I'll explain you that in the upcoming sessions. So 0.3 bar or any number of this type, 0.5 bar or 0.25 bar. This bar means that 25 is repeating, 0.25, 25, 25, which never ends. Okay, so non-terminating repeating. So terminating non-terminating repeating comes in rational numbers. There is another type of decimal which is non-terminating non-repeating, which you get from non-perfect square numbers. When you find the root of 2, there is a root of 2, but it is never ending and non-repeating also. Yes, we can find the value of root 2. Don't think that it doesn't have a root. It has a root, but it's in decimal, 1.4142, goes on, and it never repeats like it was repeating the previous question, previous term. This was repeating here. Here also we have decimal, but it is non-repeating. Okay, like if I can write any number like 0.10101000, so on. Okay, so nothing is repeating here. Okay, there is no pattern. Okay, like it's not like 1011010. I can say that's repeat. So here 10100, okay, 1000. This type of numbers which do not repeat are called irrational numbers. So numbers which cannot be written in the form of p by q. Okay, so which numbers comes in this? The square roots that are not perfect are irrational numbers. So non-perfect square numbers, all the non-perfect square numbers comes in irrational, and to your surprise even pi is irrational. You know the value of pi, that is 22/7, but when you divide 22/7 you will get non-terminating non-repeating decimal only. Okay, so because of that pi is an exceptional case. Pi is a fraction 22/7, but it is irrational number. Okay, and even e, this you don't have this concept of e, so you can leave it here. Okay, so these are the irrational numbers. So you hope you are clear with the different types of numbers. Yes, so real numbers, coming back to this now, real numbers is the head of the family, and there are two members in real numbers family, that is rational and irrational. Now rational numbers has its own family of integers, whole numbers, natural numbers, perfect square numbers, √4, √9, √16, so on, and terminating decimals like 0.5. I took the example of 0.5, or 1.3 bar, repeating decimals. Okay, decimals which repeats. So these are the members. Then irrational numbers family, all non-perfect square numbers, you can see √2, √3, √10, any non-perfect square number. Pi is also irrational numbers. So this is the classification of numbers. For further explanation you can have a look here. I have given some more examples, okay, which I have explained just now. Then these are the examples of rational, and these are the examples of irrational numbers. Hope this concept of numbers is clear to you all. So today just we have discussed different types of numbers, and we classified them into rational and irrational. Okay, thank you.